Okay, so we have the class being recorded. Even before I start that, I just want to remind you that today is midterm day. Your midterm will be available on Blackboard starting at 2:00 this afternoon. It will stay on Blackboard. It will be available until tomorrow, Friday at 4 p.m. Make sure that you complete the midterm in that allotted section of time. Also remember that when you're taking the midterm, once you start it, you have to complete it in one sitting. You can't start it, then take a coffee break and your computer, shut down your computer. If you shut down your computer, it will automatically submit your test. If you take more than the 75 minutes allotted, it will automatically submit your test. If you started at 5 to 4, it's not going to give you the whole amount of time that you need because it's going to submit because it's only available from 2 until today until 4 tomorrow. If you have any problem with your internet or any problem with the test and it automatically submits, send me an email. Now, if you're doing this at 2:00 in the middle of the night, don't expect me to be up at that time. I will check my emails regularly. And if I see that somebody has a problem, I've done this with test 1 for Blackboard. This is also would be true for any test that you take on Blackboard. As soon as I see there's a problem, I can reset it for you. Unfortunately, it doesn't work like Delta Math. In Delta Math, I can reset any individual problem. I can reset the whole test or just an individual problem. On Blackboard, the only option I have is to reset the whole test. So if you make a mistake, if you have a problem, you're going to have to start the test all over again. And just keep that in mind. Of course, you'll get the full amount of time for the test, but you will have to redo the whole test. It'll be a similar test, slightly different, but it will not be the same test. Okay, so I see people have been sending me in solutions, so let's just do this together so we can make sure we're okay with this. Again, these topics, this is called rational expressions, this is fractions, is not on the midterm. The midterm is through chapter 4, which the last topic in chapter 4 was basically factoring and solving quadratic equations. So this is not on chapter 4. This is not on the midterm. If anybody has any questions that they'd like to ask me in regard to the midterm, in terms of topics, you can let me know either in the chat, and then I'll leave some time at the end of the period to do it. When I looked at the marks on test 1, which is pretty good idea of what's going to be on the midterm, most people did okay. So I'm not doing a complete review unless there is a topic that somebody wants me to review. Then send me a chat, something in the chat, and I will then go over that topic. Okay, so let's look at the first one. The first one is just a matter of combining two fractions. It happens to be a subtraction problem. We want to get this in written as a single fraction in as simplified as we can. And if we recall, what we have to do when we're adding or subtracting fractions is we have to find a common denominator. And if you recall the method that I told you to use to find a common denominator, if your denominators include any kind of polynomials, factor your polynomials as much as you can. Well, this is a polynomial, it's a binomial, but there's nothing to factor, and this is nothing to factor. After you've done all your factoring, then either in your head or with an actual pen or pencil, go to your first denominator and circle all the factors in that first denominator. In this case, there's one factor there, it's just x plus 2. Then go, if there were more factors, I'd circle every single one of them in that first fraction. Then I go to my next fraction. And look, do I have an x plus 3 already factored? I do not, so I have to, already circled, so I have to circle x plus 3. And if there's a third fraction, go and again, circle anything that was not circled previous. Then look at all your circled factors, which in this case is x plus 2 and x plus 3. Taking them together is going to be your common denominator, your LCD. Our LCD for this particular problem is x plus 2 and x plus 3. And notice when I'm working with adding and subtracting fractions, I always want to leave my fractions denominators factored. Okay, once I've picked out my common denominator, I then compare my original fraction to the denominator, my first original fraction to my common denominator. Now, if you look at the first fraction, I see that I have an x plus 2 there. I'm checking this off, which means what I didn't have was an x plus 3. So I have to take the 5x of the original fraction and multiply it by this new factor x plus 3. I'm going to do the same thing to the second fraction. I'm going to compare the original denominator to the new denominator. Okay, the x plus 3 is here. What I have new is x plus 2. So I have to take the 8x and multiply it by the x plus 2. Notice I'm just making sure that I'm multiplying the top and the bottom by the same thing. So really, I'm not changing the value because of the top and the bottom of a fraction are the same. It means the number is 1. So I'm just multiplying by 1. That's not changing anything. Once I've done this, I just work with the numerators. What are my numerators? Well, my numerator is the 5x times the x plus 3 minus the 8x times the x plus 2. And this I have to remove the parentheses and combine the like terms. So 5x times x is 5x squared. And 5x times 3 is 15. And then I have a negative 8x. I'm including the negative of the subtraction with the 8x. So it's negative 8x times x, which is minus 8x squared. And the negative 8x times the 2, which is negative 16x. Don't forget, I have to use the distributive property. And combining all the like terms, what I have here is a 5x squared and a negative 8x squared, which together combines to negative 3x squared. And then, I'm sorry, this was 5x times 3, which is a 15x. I'm sorry, I left out that x. And then I have a 15x and a minus 16x, which is just a minus x. And after I've combined all the like terms, I put it over the common denominator. Don't forget that last step. You could try factoring the numerator and see if you get something that you can reduce. If not, you could just leave it like this. Let me see if, and I see that some people, Ariana, it should be a minus x, not a plus x. And it's not necessary for you to, you could multiply these two back together, but it's not necessary. You could leave them in their factored form. Adina, that's good. That's a good answer. Excellent. And Reggie, I see you got it right also. Very good. Okay, so that takes care of our first question. Let's look at the next one. And I'm going to start over here, but I may need more space over here, and then I may erase some of what's over there. But let's look at this. This says solve, and I have 5 over 2x equal 1 over x plus 3 over 4. So this is telling me that what I have here is an equation, and what I have to do is solve this equation. In other words, find what value of x makes this true. This was just a combining, or what they say, do the indicated operation. We were just subtracting. But this is actually solving an equation. Now we start this really similarly to where we start adding and subtracting fractions. We have to find the least common denominator. And actually, this is going to be easier to find the common denominator because since each of my denominators are single terms, they're all monomials, I can just pretty much do the finding the common denominator by just inspecting. First of all, I look at the numbers, the coefficients. There's a 2 here, a 1 here, and a 4. The combination of 2, 1, and 4, the common denominator is 4. So that'll give me the number. When it comes to the variables, the letters, I just look at all the letters and I see just the only letter I see is an X. I pick the highest exponent that I see, and they're both X to the 1 or just plain X. So my LCD is 4X. What I do with that least common denominator is I put it over 1, and I'm going to multiply the whole equation by this least common denominator. So I'm going to have to multiply this whole equation by 4x over 1. Now, when I'm doing the multiplication, I'm going to use the distributive property. I'm going to multiply each term in my fraction on both sides by this 4x over 1, which will give me, let's go over here, 4x over 1 times 5 over 2x equals 4x over 1 times 1 over x plus 4x over 1 times 3 over 4. All I did was I took this thing and multiplied it by each term. And now I'm going to simplify these. I'm going to do the actual multiplication. Since I picked the least common denominator to multiply by, every denominator that I have is going to cancel out. In this first question, the 2 cancels into the 4. That gives me 2. And the x cancels out with the x. Of course, that leaves me a 1 in the denominator. So what I'm left in the numerator is just a 2 times the 5, which is 10. Notice, now you have to do this carefully and neatly. The bottom was 1 times 1, which is just 1. Since my denominator is 1, I don't have to put it in. Okay, let's go to the next fraction. I have a 4x over 1 times a 1 over x. Here, the x cancels out into the 4x and leaves me 4. Remember, we're dividing. We're not subtracting, we're dividing. X into 4x, the x's cancel out, I'm left with 4. I now multiply the 4 times 1, which gives me 4. The 1 times 1 in the denominator. Remember, I told you their denominators are all going to cancel out. I'm just going to have 1s in the denominator. I don't have to put it in. And finally, on my last fraction, the 4x cancels into the 4 cancels into 4x and leaves me x. The 4's cancel out. And now I have x times 3, which is 3x. So that whole complicated equation that had a bunch of fractions in it turned out to be just the equation 10 equals 4 plus 3x. Well, I want to finish that equation. That's easy to finish. I'll subtract 4 from both sides, which will give me, let me just go over here. It'll give me 6 equals 3x. And then I'll divide both sides by 3 to get my answer 2. And the answer to this equation was x equals 2. And I saw a bunch of people did get that answer. So that's where we were when we finished on Tuesday. We had gone through all sorts of adding and subtracting of rational expressions, and then we started solving equations that had fractions in them. We only did the type that had denominators that were monomials. So I'd like to go on from here and talk about what happens when we have polynomials in our denominator. How do we solve those type of questions? And you'll see that we really are already able to do that. So let's take an example that looks like this. Okay, is it okay if I erase? I'm going to do, I think, 2 problems with you, and then I'll let you try one on your own. So here we have an equation, x over x minus 2 plus 2/3 equals 2 over x minus 2. This is what. Okay. And again, the instructions are solved. We see it's an equation. We also see it has fractions in it. It is what we call a rational equation. And what we did before is we multiplied everything by the least common denominator. So the first thing I have to do is to find the common denominator. And in order to do that, I have to factor any denominator that needs factoring. Well, it turns out none of these denominators can be factored. This is as simple as it can be. This is as simple as it be. This is as simple as it can be. So now we're at the second step. We go to our first denominator and circle all the factors, which is just x minus 2. We then go to our second fraction and we circle all the different factors in there, which happens to be just 3. And then we go on our other side to that fraction, and I see that I already have an x minus 2 circled, so I don't have to circle that. My LCD is the 3 and the x minus 2. Now, I could have put the x minus 2 first and the 3 second. Usually, it looks more regular if you have the number in front, but it wouldn't make a difference if you did it the other way. You take your common denominator and put it over 1, and then you're going to multiply every term in your original equation by this LCD. Now, instead of me rewriting the whole thing, I'm just going to do right away, do the distributing. It's good because I have to distribute, I have to multiply to each one. So it's going to be the 3 times x minus 2 times the x over the x minus 2 plus the 3 times x minus 2 over 1 times 2/3 equal the 3 times x minus 2 over 1 times 2 over x minus 2. When you're doing these type of examples, give yourself plenty of room and plenty of paper, because the most common mistakes that are made are you cross something out and you can't see what's there. Okay, now, going to my first fraction. Remember, every denominator is going to cancel out. Here, this x minus 2 cancels into this x minus 2. And all I'm left with is 3 times x over 1. I don't have to put it over 1, because over 1 means a whole number. In my second fraction, the 3 on top cancels out with the 3 on the bottom. Again, I'm left with only 1s on the bottom. So my second fraction becomes the 2 times x minus 2. Again, if you wanted to, you could put the x minus 2 times 2. Doesn't matter the order you put it in. You're multiplying, so it doesn't make a difference. And finally, in your last, on the other side of the equation, you have to multiply by everything on both sides of the equation. The x minus 2 over here cancels out with this x minus 2 here. Again, my denominators are 1, and I'm left with 3 times 2. Now, if you wanted to, you could have done the multiplication as you go around. I just wanted to get the final equation. If you notice, this is not a hard equation to solve. We remove our parentheses, we get 3x plus 2x minus 4 equals 6. The 3x plus the 2x gives me 5x. The 4 I could have brought to the other side right away. So that gives me 5x equals 10. And to finish that, I divide both sides by 5, and it gives me x equals 2. Notice the hard part was finding the common denominator and multiplying through by it, because the whole point of doing that is to make yourself a very simple equation to solve. The answer we got is x equals 2. Okay, I want to show you something interesting. I did not bother to check the equations that I did before. But really, one way of telling if you've done something right when it comes to solving an equation is by checking the answer. it's possible to check the answer of an equation. Let's check this equation. Here's my check. How do we check the equation? The answer I got was x equals 2. I'm going to go back to my original equation and replace the x with 2. That's how we check. So I'm going to do 2 over 2 minus 2 plus 2 over 3 equals 2 over 2 minus 2. I just replaced the x by 2 because that's what it came out to be. Now, if I simplify each of this, this becomes 2 over 0, because 2 minus 2 is 0, plus 2 over 3 equals 2 over 0. And something very strange has happened. The one thing we're never allowed to do when it comes to arithmetic is to divide by the number 0. You cannot divide by 0. We called that undefined, but really what it's impossible to do. You're never allowed to divide by 0. And here, this, if I take this answer, it's making me divide by 0, which means that this answer is not a good answer. It's something called ambiguous. It's called something, it's the term used for this is an extraneous solution. If you see in the word extraneous, and extraneous happens to be an English word, it's not a mathematical. If you see in the word extraneous, you see the part extra. It's not an extra solution. It's an extra solution that we don't want. That's what extraneous is. If you have something extra that it's no good and you don't want it, that's something that's extraneous. What do we do with an extraneous solution? We throw it out. In other words, for this problem, there was no solution. Because the one solution that we got didn't work. It made the denominator equal to 0. You could either write no solution, or you could write it with this 0 with a line through it that's called null set, means no solution. Or you could do even this. You could just do these empty brackets that also, all these indicate no solution. But don't write x equals 2. X equals 2, even though we did all the right work, didn't work. It's not a good answer. There was no answer to this problem. And the only way we could do it was to actually do the problem and check, which tells us something very important. When it comes to rational equations, it's not only important to solve, it's important to make sure that your solution is a good answer, that it's not extraneous, which means it can't make the denominator equal to 0. All right, are you ready to try one on your own, or should we do one together still? Everybody okay to try it on again? Try one? Okay, let me give you one more. Okay, Renee, let's do one more. Okay, I'm erasing this. We're doing another one, then you get one to try. Let's say I gave you this problem. Suppose I give you this, x plus 6 over x plus 3 equals 3 over x plus 3 plus 2. Let me just start you off on this. Where you have an equation or you want to add fractions, and some are whole numbers and some are fractions, take your whole number and put it over 1. So it keeps everything, that way you'll keep the idea that 2 is the numerator and the denominator is 1. Any whole number can be written as a fraction over 1. Okay, so let's do the steps that we did before. We're going to find the common denominator. Notice again, nothing had to be factored here because everything was factored. And the only common denominator, I have an x plus 3, this I already have, and 1 is, you don't have to count because 1 times anything is that original example. So my common denominator is going to be x plus 3. So I'll put the x plus 3 over 1 and multiply it by the whole fraction. I'm going to multiply everything by x plus 3 over 1, which means I'm going to multiply the x plus 6 over the x plus 3 and the x plus 3 over 1 times the 3 over the x plus 3 and plus the x plus 3 over 1 times 2 over 1. Just like we did before. We multiply every single term, every single fraction that we have by the common denominator over 1. Okay, so in this first set of fractions, the x plus 3 on top cancels with the x plus 3 on bottom. I'm left with 1s here. And all I'm left with is 1 times x plus 6, which is x plus 6. Again, we'll know we're on the right step because the bottom should all turn out to be 1s. Now we're at our second one. Here the x plus 3 cancels with the x plus 3 as well. 1s, so I get 1 times 3, which is just 3. And finally, over here, nothing cancels out, so I just have the x plus 3 times the 2. Well, I'm going to put the 2 in front. So this is what my equation turns out to be after I multiply by the common denominator. Okay, let's combine our like terms. This is x plus 6 equals 3 plus 2x plus 6. And so writing a sum, combining the like terms, this just becomes 2x plus 9. So I'm going to subtract x from both sides here, which will give me 6 equals x plus 9. And now I'll subtract 9 from both sides. So my final answer comes out to be, I'm going over here because I'm running out of space, -3 equals x. In other words, the solution that I got is -3. Let's see if that -3 is a good solution. When I go to check, and if I don't have a lot of time, all I have to check is the denominator. Does it make any denominator equal to 0? And the first fraction is -3 plus 6 over -3 plus 3. And look at this. This is 0. I don't have to go any further. This is an extraneous root. There is no solution. Okay, so again, We find the common denominator, multiply everything through by that common denominator to get rid of the fractions, solve it. But don't forget, if you don't have time to do the whole check, just make sure, look at your denominators and make sure they're not turning out to be zero. Is that better now? Is that clear?
Yeah.
Okay, so now I'm going to give you one to try. And while you're doing that, I'm going to take attendance. So don't forget to listen in. Here's a question for you. So, see if you can solve this equation. Two over x minus 3 plus 1 over x equals 1 over 2x squared minus 6x. Okay, don't forget, the first thing you got to do is find your common denominator and then multiply everything through by that common denominator. Moriel Labre. Hi, good afternoon. Chelsea. Chelsea here? Ariana.
Here, good afternoon.
Good afternoon. Okay, Chelsea, I'm glad you're here. Adina, I know you're here because you were here the first person. Lachey, I think you were also one of the first. Lachey?
Yeah.
Kava Collingwood?
Here.
Hi. Terrence Cruz? Karide? Hi, Karide. I didn't notice that you had taken the test. Did you, are you able to get to your Blackboard account? Karide? Kizia?
Here.
Hi.
Hi.
Who are we talking to? Faith Diggs? Faith, are you here? Ethan?
Here.
Hi. Isabella? Yes, I did call you Terrence. Okay. Got you now. Serenity.
Here.
Hi. Reggie, I know you're here. 'cause you-
Here.
Zamia. Zamia Grady.
I'm here.
Hi. Were you here on Tuesday?
I'm trying to remember. I think I was, but I'm not sure. I don't remember. I'll check.
Okay. Brandon.
Here.
Hi. Michaela. Michaela here?
So I'm here.
Hi.
Hi.
Seraphine.
I'm here.
Marissa. Marissa here? Renee here?
Here.
Yeah, hi Renee. Hi, I think I saw you sent me a text. Okay, see you're having trouble. Okay. Okay, Sky is here. Jaden Roberts. Jaden. Jaden here? Kennedy, I think you sent me a text already. Kennedy, are you here?
I'm here.
Yeah, okay, thanks. Felicia Simon,
I'm here.
hi. Natalia Small,
Here.
hi. And Michael Todd, I think you already wrote me that you're here. Okay, Michael, you're here. Cassidy Tucker,
Here.
hi. Megan. Megan, hi, Megan. Kalia, Lauren Whaley,
Here.
hi. And Kayla Zachary. Kayla Zachary, okay. And I understand completely if you have trouble with your internet, that's what happens. Okay, let me just check that I'm right. I have 1, 2, 3. Five. I'm missing somebody. If somebody did not hear their name, then please send me a chat. Okay, I see people are giving me the answers also already. So, let's see if we can work this problem out. Okay, this one's a little bit harder than the ones that I gave you before, because this one, you really have to factor your denominators. Obviously, I can't do anything with the x minus 3 and the x, but the 2x squared minus 6x has a common factor of 2x. So it's 2x times x minus 3. And if I do what I did before, I'm going to start with my first denominator and circle all the different factors in that first denominator, which is the x minus 3. That's all there is there. Then I go to my second denominator, which is x, and I have to circle that. It's not, don't think it's already included in this x minus 3, because it has to be, as a binomial, it has to be the exact same thing. And then I go to my third fraction, and the denominator is a 2, an x, and an x minus 3. Now, the 2 and the x are factors, because this means 2 times x. And I don't have any 2 listed, but I do have the x listed, and I do have the x minus 3 listed. So my common denominator turned out to be the 3 factors, the 2, the x, and the x minus 3. Now, I don't have to have the 2 and the x in their own separate parentheses, because they're monomials, they are factors. But the x minus 3 has to be in a, because we have to keep in mind that that's 1 unit. I put this common denominator over 1, and I'm going to multiply by every term in that fraction, in that equation. So it's going to be the 2x times x minus 3 times the 2 over x minus 3 plus the 2x times x minus 3 over 1 times 1 over x. I'm just multiplying this by each term. And on the other side, I'm also going to do the 2x times x minus 3 over 1 times 1 over 2x times x minus 3. Notice I use the factored form to do this. Notice how much space I need. Give yourself plenty of space. You don't want to get it wrong because it was so cramped and you couldn't read what you had there. Okay, now I'm ready to do each multiplication. So in this first set, this x minus 3 cancels out with the x minus 3. I know I'm on the right. The bottoms have to turn out to be 1. So what I'm left with here is the 2x times the 2. I'm just writing what I have left over. I'll do the work a little bit on the next step. Over here, I have the x over here cancels into the x. Because x does divide into 2x, that gives me just the 2. So I'm left with 2 times x minus 3 times my 1. I don't even have to put that in because 1 times anything is just what was there before. And finally, over here, the 2x, and the 2x cancels out, and the x minus 3 and the x minus 3 cancels out. And I'm left with only 1s, so by it's 1 times 1 just gives me 1. Notice I did all the hard work. Now I have easy work. I don't have any fractions left. I just remove my parentheses. This is 2x times 2, which is 4x, plus 2x minus 6 equals 1. I can add the 4x and the 2x, and that'll give me 6x. And the 6 I want to bring to the other side. So that gives me 6x equals 7. And the answer I get is 7/6. I just have to make sure it's not an extraneous root. It would be very hard to check with 7/6, but I certainly can see that when I do 7/6 minus 3, it's not going to be 0. The only thing that would make this 0 would be another 3. It's certainly not making this 0, and this is just the 7/6 times 2 times 7/6 minus 3 is also not 0. It's not making any denominator equal to 0. It's not an extraneous root. So if I've done the right work, and I assume I have, my answer is 7/6. And I think, was it Adina that you got that answer? Excellent. Okay. I think we're pretty much finished with solving rational equations. It's important you have to know how to do it. Remember the steps. You find the common denominator, you multiply every single term, every single fraction in the equation on both sides by that common denominator so that everything cancels out in the denominator, so you're just left with an equation that has no fractions in it. Solve that equation. And that's going to be your answer. Just make sure it's not an extraneous root. It's not making any denominator equal to 0. Okay, there's one more topic left in this chapter, and that has to do with division. In chapter 4, we talked about polynomials, and we talked about adding, subtracting, multiplying, and factoring polynomials. In chapter 5, we dealt with fractions, rational expressions. But the thing that we haven't ever really touched is division of polynomials. Now, division of polynomials very often will leave you with fractions, because one way of indicating a division is to use it as a fraction. So the last topic in chapter 5, the chapter we're doing now, is division of polynomials. And we're going to do it in 2 stages. We're first going to talk about dividing polynomials by monomials, and then we'll talk about dividing a polynomial by a polynomial. That will complete chapter 5. Now, chapter 5, let me remind you, is not on the midterm, but it certainly will be on the final. I will be assigning homework from chapter 5 on Delta Math over the weekend. There will be homework due for Tuesday. I probably won't post it until tomorrow, but you will have homework on Delta Math. Don't forget to keep looking at it. If you haven't done all your homeworks, I've set it up so that the homeworks on Delta Math can be done throughout the term. You don't get full credit. You get 90% of your credit if you do it late. But it's better that you do it late than you not do it at all. So make sure you've got to do all the homeworks. Keep checking Delta Math to make sure you're doing the homeworks. Okay, so we're now going into division of polynomials. So first, let's try the problem at once. I have 10x to the 5th minus 15x to the 4th plus 5x squared over 5x squared. And the instructions are to divide. It's important to look at these instructions because sometimes it'll say simplify, and that means factor everything. And sometimes it says divide. And in this case, we want to divide. You can write a fraction, a division as a fraction, or you can use it with the division sign. When the term says divide, and you have a polynomial, it's a trinomial on top, divided by a monomial, what you're supposed to do is take each term of your polynomial and divide it by the monomial. In other words, rewrite the question as 10x to the fifth divided by 5x squared minus 15x to the fourth divided by 5x squared plus the 5x squared divided by the 5x squared. If you're dividing a trinomial by a monomial, you're going to end up with doing 3 divisions. If you had 10 terms on top, you'd be doing 10 divisions because you have to divide every term in the numerator, in this is called the dividend, by the divisor, by the denominator. And we do each one separately. Remember, we know how to do this. The coefficients we divide, notice there's a 10 on top and a 5 on the bottom. I can cancel out the 5, and 10 divided by 5 is 2. When it comes to the variables, I always cancel out. I cross out the one that has the lower exponent. Now notice everything's crossed out from the bottom, so I'm putting a 1 there. And what I do is I subtract that smaller exponent from the larger, so 5 minus 2 is 3. That leaves me x to the third. And keep in mind, it's canceled out where the lower exponent is, the smaller exponent gets canceled out. The answer is left where the larger exponent is. So therefore, the x to the third, in this case, was left on top. And if you notice, this one fraction came out to be 2x cubed over 3. Anytime you have a 3 in a denominator, you don't have to put in that. I mean, anytime you have a 1 in the denominator, you don't have to put in that 1. You could just write it as 2x cubed. If you wrote it 2x cubed over 1, that would be fine as well. Okay, now we go and do the same thing to the next. There's a 15 and a 5, so this will be a 3, and this will cancel out. And this is the lower exponent, the x2, so there's my 1, and 4 minus 2 is 2, so I'm left with minus 3x squared as my second term. And my third term, the 5 cancels with the 5, the x squared cancels with the x squared, and my final answer then becomes 1. Don't make the mistake of not putting in that 1. When you're dividing and everything cancels out, you are left with a 1. And this is your answer to the division, 2x to the third minus 3x squared plus 1. Again, it's a matter of just dividing each term by the denominator. Okay, I think you could try one of these. Let me give you one to try. Let's do this one. This one here, you can do this by yourself. Give you a couple of minutes. $15 a third b plus 30 a squared b squared plus 20 ab to the third divided by 15a squared b squared. Okay, I'm going to give you a few minutes to try that.
Wait, do we need to simplify this?
You really, do you mean by factoring it? No, you do not have to factor it.
Oh, okay.
When it says divide, they just want you to actually do each term, and they don't care if you factor it or not. Okay, let's see, we have some people coming up with answers already. I'll give you one more minute. Okay, I think we can do this now together. Again, I'm gonna do what I did before. I'm gonna take, since it says divide, I'm gonna put each term from the numerator over the denominator. So I'm gonna have 15 a third b over 15a squared b squared plus 30 a squared b squared over 15a squared b squared plus 20 a b to the third over 15a squared b squared. Okay, so I just separated and I have three problems now that I have to do. The first one, the 15, remember I deal with the numbers, the coefficients, and then I deal with the variables. So the 15s cancel out. Then I have the a's. There's an a3 on top and an a squared on the bottom. The lower exponent is the a squared, so that gets canceled out. And I subtract 3 minus 2 gives me 1, so I get a to the 1, which means just a, and it's on the top because it's always left where the larger exponent was originally. Then I have a b and a b squared. The lower exponent is the b that's on top, and if I do 2 minus 1, I'll get b, but it's in the bottom because the higher exponent is in the bottom. We cancel out the lower one and we leave our letter, our variable where the higher one was. And if I look at it, the only thing that was left on top was an a, and the only thing that was left on the bottom was a b. So the first term is a over b. Okay, going to my next fraction, I have a 30 and a 15. This becomes a 2, and this cancels out because 15 does divide into 30. I have an a squared on both, so they both cancel out, and a b squared on both, so they both cancel out. Everything canceled out from the bottom, so I had really 2 over 1, which I could just write as 2. Remember, when 1 is your denominator, you don't have to put it in. And finally, the 20 and the 15, what I can cancel out from both of them is a 5, so I'll be left with a 4 on top and a 3 on the bottom. And then with the variables, the a alone cancels out. I'm left with a on the bottom here. And the b third and the b squared, the lower one is the b squared, so that gets canceled out, and 3 minus 2 is 1, so that's b. So my last term, fraction, my last term becomes 4b over 3a. And this is what your answer should look like. Just do it carefully, each one individually, and it will all work out. Reggie, what you did is you simplified the fraction. That's not division. It's called reducing the fraction. And reducing the fraction and division are really slightly different. Notice I'm not left with one fraction, I'm left with three different fractions. That's what we want to do when we're doing division. Okay?
Yeah, I see it.
So now I just want to start the next topic. We now know how to divide a polynomial by a monomial. What happens if I ask you to divide a polynomial by a polynomial? Specifically, we're only going to divide by binomials, two terms. Division by polynomials is quite difficult. There are two methods. One's called regular long division and one's called synthetic division. The method we teach is the long division method. The advantage of the long division method is they can use it for any long division. The synthetic division method works in some cases, but not in all cases. So again, you may learn that in a different course, but in this course, we do long division. And since it really is the way we did long division with numbers, I'm just going to do a long division with numbers to remind you. I know most people, if they have a division problem, all they do is they take out their calculators and they use their calculators because nobody likes to do long division. It's so long and complicated, but we have to remember the method. So let me go through the method of just regular long division with numbers, and then I'm going to show you how it applies to dividing of polynomials. So if you remember, if you wanted to divide, let's say, the number 25 into the number 4628, you would start with a 25 and you'd say, well, does 25 go into 4? And obviously it doesn't. So then you do the 25 into the 46 and you sort of try to estimate it. And it's like about 3 into 4. It looks like it goes one time. And you have to be careful to put the 1 on top of the 6 because you're doing the 25 into the 46. So step 1 is you divide your divisor into your dividend. The outside is called the divider or divisor. The inside is called the dividend. That's what we're dividing into. So we do this division and you put your answer on top. And then what you do is you take your answer that's on top, which in this case is a 1, and multiply it by the divisor. So 1 times 25 gives you 25. So that's our next step. Take what you put on top and multiply by it. And the next step is, to remember this, you subtract. You're going to do 46 minus 25. Now, when it's going to come to algebraic expression, we're going to do the subtraction the way we do subtraction of algebraic expressions. But this is easy. This is just number subtraction. 46 minus 25 gives me, there's a 1 here, 21. After you've done, so this was step 3, was to subtract. And your next step, after you've subtracted, is to bring down the next number, which in this case is the 2. So that's step 4. You bring down, so we divided, put the answer on top, multiplied, subtracted, and we brought down the next number, which was a 2. And now we start the whole process again. We take the number on the outside, the 25, and divide it into the 212. So 25 into 212, I think it goes about 8. I'm guessing. I'll know if my guess is good if when I multiply, the number I get is going to be less than this, but what I subtract, it's going to be less than 25. In other words, here I'm gonna multiply, I take what I just put on top, which is the 8. 8 times 25 I know is 200. And when I do 212 divided by 200, I'm left with 12, which is good. It can't be more than 25. So again, I divided, put the answer on top, multiplied by the answer I had just put on. I don't use the 1 anymore, I just use the 8, and then I subtract. And again, now I bring down the next number, and I divide again. I start all over. 25 into 128 goes, I think, 5. I take the number I just put on top, which is the 5, and multiply it by the 25. So 5 times 5 is 25, and 5 times 2 is 10. When we had 2 from before, it's 125. And again, we subtract. Now, there's nothing more to bring down. We're not doing this like one way of doing this is to put a decimal point and then another 0, so you'll have more to bring down. But we're not doing that. We're doing what's called division with remainder. The answer 3 is the remainder. We say the quotient, that's the answer in the division, is 185 with a remainder of 3. An alternate way of writing that is to write it 185 plus put the remainder over the divisor, plus 3 25ths. Usually we don't even put the plus in between them because we could have just written this as 185 and 3 over 25, because when you have a fraction next to a whole number, it means that it's what we call a mixed number, and it's this whole number together or added to this number. We can't do that with algebra because usually when you put two things together with letters, with variables, it means that you're multiplying. This does not mean multiplication. It means this plus this. The better way would probably be to write it this way. Okay, so that's the steps of long division. Let me show you how this applies to dividing of polynomials. So I'm going to erase this because I need the space, but I'll leave these steps here because you're going to see that that's the steps we're going to be doing. So let's say I gave you this example. I have 2x squared minus 7x plus 9. Divided by, that's what it said, be careful to read the instructions, x minus 2. So the first thing we're going to do, I have a polynomial, it happens to be 3 terms, divided by a polynomial, it happens to be 2 terms. This is a trinomial divided by a binomial. What we want to make sure is, first of all, our terms have to be in what we call descending order. X squared, x number. If there is an x to the third, it would have to come first. We need them in descending order. We have to arrange our terms in the proper order. And then we write it like a long division. In other words, we put the x minus 2 on the outside and the 2x squared minus 7x plus 9 on the inside. And our first term step is to try and divide the x minus 2 into this whole thing. Well, I can't do that. That's our problem. It's hard to do. So instead of doing the whole thing, just take the first term and divide it into the first term. That'll give us a good enough answer to put on top. So this is a 1x. I'm dividing it into 2x squared. So first term into first term. 1 into 2 gives you 2, And x into x squared gives you x. Because again, when you're dividing, you're subtracting their exponents. It doesn't matter where on top you put the answer. It's not, you don't have to be so careful as you are with regular division. After you've done the division, you're up to the multiply. When you multiply, you take what you just put on top and multiply it by the whole divisor, the whole binomial. You multiply the 2x times the x, which will give you 2x squared. And the 2x times -2, which will give you -4x. Okay, so we divided, we multiplied, we're up to subtracting. Now remember, we are subtracting polynomials. It's the polynomial 2x squared minus 4x that we're subtracting from the 2x squared minus 7x. And I think the easiest way to do the subtraction is to change the signs of what we call the subtrahend. This is really a plus, so we're going to make it a minus. This is a minus, we're going to make it a plus. And then we can just combine the like terms. That's the easier way to do subtraction with variables, with algebraic expression. So I'll have a 2x squared minus 2x squared, and that'll cancel out. And then I'll have a -7x plus a 4x. Remember, this is really -7x minus 4x. I change the sign so I don't have to remember that I have an extra minus in there. So this is -7x plus 4x, which is -3x. And now that I subtracted, I bring down my next term, which is +9. And I start the process again. I take the 1x and divide it into the -3x. First term into first term. Well, the x's cancel out, and all I'm left with is -3. So I put my -3 on top. And now I take what I just put on top, which is this -3, and multiply it by the divisor. -3 times x is -3x. -3 times -2 is +6. I'm up to subtract it. Okay, I want to do it algebraic method. This is a minus, so it'll become a plus. This is a plus, so it'll become a minus. So the -3x and the +3x cancel out. And now we're left with 9 minus 6, which is 3. And this is actually my remainder because there's nothing else to bring down. So my answer comes out to be 2x minus 3, my quotient, which is what's on top, remainder 3. Or a better way to write it is 2x minus 3 plus the remainder, the 3, over the divisor x minus 2. This is probably the better way to write the answer as a quotient and remainder over the divisor. Should I do one more? Should we do one more just to make sure we have this under our belts? I see a lot of people. Would you rather to just be, have some time? Should we stop right here? Okay, I think most people are ready to end this session. So this is where we're going to be starting next time. We're going to review again. I'm not going to give you homework on this, on the division by a polynomial by a polynomial, but there will be homework on Delta Math for it tomorrow. Today, your homework is to make sure you do the midterm. Remember, you have starting in a half, it's now 1:30, starting in a half an hour, you could access it, and you'll have until tomorrow, 4 p.m. Just set yourself down with at least 75 minutes time, give yourself, you may not need all the time, but give yourself the option of using the whole time and do it all in one sitting. Again, your option is when you want to start it. Okay, have a good weekend, everybody, and I hope everybody does well on the midterm, so then they will have a good weekend.
Grande, professor.
Bye. And we'll start with this division next time.